In Smells Lesson 2, we're going to be focusing more on molecules in two dimensions, but looking more at the structural formulas of chemicals and how that affects their smells. And so the purpose of today, again, is going to be comparing structures of molecules and the smells that they give off. Again, we're going to have 3 vials now that are going to have different smells in them, just like in Lesson 1. The vials are F through H. And so what you're going to do first is you are going to make predictions on what smell you expect the following vials to smell like. And we may do this by looking at the different either names or molecular formulas and going back to Lesson 1. I see that in my molecular formulas, they all end in O2. They have 2 oxygens. Going back to Lesson 1, we said that chemicals that have 2 oxygens in their formulas have a sweet smell. So I'm going to predict that all 3 having O2 are going to be sweet. Also looking at the name to help us determine if we think our predictions will be correct. Sweet smelling chemicals end in 8. They have an 8 ending in the name. Vial F and vial H both have an 8 ending in their name, but G does not, though it has 2 oxygens. So I'm still going to predict that it's going to have a sweet smell, but we'll see. So what we'll do is the same as before for F, G, or E, F, and G. Oh, F, G, and H, my apologies. For F, G, and H, we're going to smell the chemicals just like we did before by using a wafting technique. And when I smell vial F, the actual smell that I get is in fact a sweet smell. For vial G, we predicted sweet because there's 2 oxygens, but that name kind of seemed a little iffy because it didn't have that 8 ending. And so actually, when you smell vial G, it smells really bad. And the word we're going to use to describe that is putrid. A really gross smell. But then you go to vial H and it smells sweet again. So we have our actual smells versus our predicted smells. We were 2 out of 3 correct. But I'd like us to look for a moment at why is it that we picked sweet smell for vial G, but it gave us a putrid smell. We have 2 different names for G and H. Butyric acid and ethyl acetate. 2 different names. But looking at their formulas are actually the same. They are both C4H8O2. C4H8O2. But why is it they have different names? And by having different names, even though they're the same chemical, how did that affect the smell? The smells ended up being different. So let's look more closely at molecules G and H. In this ball and stick demonstration, the question is, how are the models of G and H different? I'm going to put a picture of models G and H, of chemical G and H. So molecules G and H, again, have the same formula, C4H8O2. I drew out molecule G. Molecule G has 1, 2, 3, 4 carbons. Carbon is the black dots. It has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And it has 1, 2 oxygens. These single lines are called single bonds. They're connecting atoms with one single bond. And we'll talk more about bonds later. But this oxygen here has 2 lines. That's a double bond. So it bonds twice, and we'll again talk about that more later. Looking at molecule H, it also has 1, 2, 3, 4 carbon atoms. It has 8 hydrogen atoms, and it has 2 oxygen atoms. Both have the same formula, same number of atoms, but give us different smells and different names. Please take a moment And in the space below, under how are the models of G and H different, I would like you to describe at least 2 to 3 ways that this drawing of G versus H are different from one another. So please pause the video now and make those observations. Okay, so at this point you should have a couple observations written down under G and H, or under how are the models of G and H different. Looking at the two models, let's go through this. They do all have the same number of carbon, oxygen, hydrogen. But one way that they are different is where this double bonded oxygen is. So location of double bonded oxygen. In G, our double bonded oxygen is on outside carbon, on this last carbon. While in H, our double bonded oxygen is on one of the inside carbons. They're bonded to 2 different carbons. That changes the structure. Also, this oxygen, this single oxygen by itself, the location of single bonded oxygen is different. That this single bonded oxygen here is attached to the last carbon, while in molecule H, that single bonded oxygen is between 2 carbon atoms. Why is that? And a third observation you could have made is what the oxygen on end of G is bonded to. What I mean by that is looking at this oxygen here, it's bonded to a carbon and then a hydrogen. While this oxygen, being the same technically oxygen as here, this oxygen is bonded to 2 carbons. So there's a lot of difference in the bonding of the molecules. That plays a big role in the different smells. And the different ways that atoms are able to bond affects the name of the chemical. And by the name being affected, the ending is affected. By the name changing, the ending of the name changes, which then in fact does change the smell of the chemical. What you will do now with a partner is you are going to examine the structures below. And so below are the 3 different vials, molecule F, molecule G, and molecule H, drawn out for you. You are going to just examine the 3 molecules and answer the 5 questions. All right? Just answer those 5 questions, and then you will be instructed as to what to do next.